All right, so scholars, we're going to do the last two examples here in the notes on ellipses, and we're going to find all the little pieces of information that are going to help us out. So, first things first, it says write the standard form of the equation of an ellipse centered at the origin. So here's our center. Okay, so there's the center. With a major axis of length 10. So that's the way it stretches, right? With foci at -3, 0. So there's one of the focus. And then the other focus is at 3, 0. Okay, now guys, what are the pieces of information we need for standard form? Also, we need to remember which way is this opening. If the focus is going horizontally, that means our major axis is also going horizontally. So we're going long width, which means our standard form is going to be x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So a is going to go underneath the x's because we're going horizontally. So it's the reason why I know that is because the foci are going horizontally away from the center. So remember, focus is on, the foci are on this major axis itself. Okay, what are things that we know based off of the given information? We know that the focus is found using C, right? So we know C, let me see if I can get the color to change here. We know the value of little c is going to be 3, right? So we know C is equal to 3. We also know in this case, I do believe, what A is. Now you're going like, how do I know what A is? Okay, now remember this says the major axis has a length of 10, which remember to find the major axis, we go to the center and then we add A to the right and A to the left if it's horizontal, or we'd go up or down. So I'm going to go, let's pick a different value here. We know A is going to be 10 over 2 is going to be 5 because I'm going to go 5 to the right. So 1, 2, 3, 4, 5 to get my vertex because that's the end of the line segment. And then I got to go 5 to the left. So we're going to go the opposite direction. So that's our other vertex point, because the length of the major axis is really just a double. Because remember, to get the vertices is we're going to go from the center to the distance of A away. So I did an A direction this way, A that way. So it's going to end up being 5. With me on that? Okay. So A is 5. Now, what's the letter that's missing that we need? We need, obviously, C. So we're going to use our formula. So, obviously C. Wow, guys. It should be obviously B, Mrs. Gregerson. But we're going to use the formula C squared equals A squared minus B squared. So what's C? C is 3, so 3 squared. We found A to be 5 because the length of the major axis was 10 and you divide it by 2. So it's 5 squared minus B squared. So we get 9 equals 25 minus b squared. Subtract the over, that's a negative 16 equals a negative b squared. B squared is equal to 16. Plus or minus, we know b is equal to 4. All right, so we got b is equal to 4. Now, if b is equal to 4, quick, easy one, guys. Remember with this, I'm going to change it to black here. If b is equal to 4, remember we can do our minor axis. We can get the co-vertices by going from a center and go up or down 4. And then this would be your your ellipse. Don't like my ellipse, so here we go. Make it a little bit better. It's almost a circle. Almost, but not quite. So now we still have to write it in standard form. Now, what are the other two pieces of information I need? I need to know the center, which is my H and K, right? If the center is at the origin, that makes H and K both 0. So here's my formula. Let's plug in what we know. It's going to be x squared because x minus 0 is x all over what's a squared? Well, a is 5. Square that's 25. And remember, we know it's underneath x, a squared is, because it's horizontally stretched out. Plus y minus 0 is y, so it will be y squared over b squared. Well, b was 4, so that'd be 16, and that would equal 1. So this would be your standard form of the ellipse. It's graphed down below. Did that help a little bit with that one? Now the next one, we're going to be using that completing the square stuff that we're talking about. Remember, that means we have an x quantity squared and we have a y quantity squared, and we want this whole thing to equal 1 when we're done with it. So it's really doing the same process, but we got to be a little extra careful about a few things, okay? So first things first, you want to be really good about putting your x's together and you're going to put your y's together. And then we're going to move, just like we did with completing the square before, move our constant to the other side. So I'm going to go 25x squared minus 200x. We're going to go plus 9y squared plus 36y is equal to a negative 211. All right, so then the next thing we need to do is we actually need to like factor out 25, because remember, when I do completing the square, I don't want anything in front of my x squared. So I'm going to rewrite this as 25 times the quantity as x squared minus 8x. I'm going to go plus blank. So I'm kind of doing a 2-for-1 step. I'm taking out a greatest common factor, knowing that I'm going to use completing the square with it. Now I'm going to do the same idea here. I need to get rid of that 9. So I'm going to factor out a 9, which leaves me y squared plus 4y, and I'm going to go plus blank. And then over here, I'm going to go negative 211 plus blank plus blank. Okay, now there's some stipulations, but just go with me. I'm going to change some colors here to make sense. All right, so just like with completing the square before, we're going to do our x squareds together. Do you guys agree with me? I take negative 8, divide by 2, that's a negative 4. I square that. So I get 16. Okay, so with this, my friends, we had that plus 16. So naturally you think over here, oh, I'm going to go plus 16. Well, guess what? No, you don't. Because what's in front of the parentheses there? A 25. Okay, so the fact is you're really going 25 times 16, which is going to be 400. So you're really adding 400 to both sides because of the 25 out front. So we have to understand we didn't get rid of that 25, so that's what we're doing. All right, as we continue. Now I'll do the same type of idea, and I'll just do a different color here. Let's do blue here. The same type of idea with the y's, okay? So I take the 4, I divide it by 2, I get 2, and then I square it, which gives me 4. But what do I add to the other side? Because remember, this one's 25 times 16 is right here. I'm going to add what 9 times 4 is, because that's really what I'm adding to both sides. Because remember, I have that parentheses, that quantity. I'm really adding 36. So then we use this process. Now I'm going to go back, writing this with black ink. What we have following is now we're setting up our completing the square part, and we'll get us really close. I get 25 times the quantity, x minus 4 squared, plus 9 times the quantity, y plus 2 squared, equals 225. So 225. Now I'm almost to standard form if, remember, standard form is x minus h squared over a squared plus y minus k squared all over b squared equals 1. Now, remember, a can change spots. I'm just saying that's standard form idea. So what I'm going to do, I'm going to take everything and divide by 225. All right, so what do we get? We get the quantity x minus 4 squared all over 9 plus the quantity y plus 2 squared all over 25 is equal to 1. So this is the standard form of our ellipse. Now, tell me what you know about this ellipse. Now, that's not part of the question. We just had to write this in standard form. But looking at what you know about this ellipse, what do you know? First, you should know your center. Your center is going to be at 4, negative 2. Okay? You should also know which direction the major axis is going. Remember, the largest value is a squared. It's under the y, which means my ellipse is be going up and down. It's a vertical stretch of my ellipse. So we're going up or down. We then could quickly solve for the foci and the vertices and all those things. So just know that's kind of the basic process of this. It hopefully will help you get started. But guys, if you have any questions, you can call me this weekend. I will be at Mr. Wah on Saturday night. Do not bring your math questions to Mr. Wah on Saturday night. But I will love to help you guys. I'll be in and out on Sunday, all that type of stuff. Just give me a call. I'll also be here before school on Monday or during lunch on Monday, like normal stuff that we do. So hope this is helpful, and talk to you guys all soon.